All right, like I said, the title of it looks a little scary, proofs, and you're probably thinking, I thought we weren't doing proofs, Mr. Hamrick. Well, we're not really doing proofs, but what we're trying to do is we're going to talk about the stuff we've already talked about, but we're going to look at it in a different way. All right, for instance, here's what. Here, let me slant the thing. There we go. All right. So this kind of looks like a what? Parallelogram, okay? And so if I told you that this was parallelogram ABCD, all right, so watch. This is parallelogram ABCD. Or a lot of times they'll use this word given, okay? So it's given that this is a parallelogram. So, and this is the key to what we're... Excuse me. Ugh. Dumb cough just hits me out of the blue sometimes. All right. So, if this is a parallelogram, that's the key word. If it's a parallelogram, then a whole bunch of stuff is true about it. All right. So let's go through some of the stuff that we know already. So if it's parallelogram, so what do we start with? We start off knowing that this thing is a what? Parallelogram. All right, so I want to make that clear to you. So this one, this is not the new lesson. This is kind of what we've already done. All right. So what we've already done, we've established, they told us that this thing's a parallelogram. So if we already know that it's a parallelogram, what do I know about, let's say, some of the sides? What do I know about this side and this side? They're parallel to each other, right? And what about these two sides? They're also what? Parallel to each other. If they tell us it's a parallelogram, agreed? All right, and that's just by the definition of a parallelogram. Then we had a theorem that said, and Svenka, you said this already, they're parallel to each other, but they're also what else to each other? The opposite sides. They're congruent to each other, right? So that must mean that these two sides are equal and these two sides are equal. Agreed? What else did we learn about a parallelogram? What else might be true about this thing? Opposite angles are equal. That's right. So A and C would equal each other, and B and D would equal each other. And we also know what's true about the consecutive angles. They're supplementary to each other. Good. We knew something about the diagonals too, didn't we? They meet in the middle. What's a better way to say that than they meet in the middle? They bisect each other. That's the word that we used, okay? So we know that the diagonals bisect each other, which means that, I'll just put this in pink, okay? So this tick mark and this tick mark, that doesn't mean they're the same, okay? It's just different color. I just don't want to write down like 15 different tick marks, okay? So this one and this one would equal each other because it's bisected, and what else? This one and this one equal each other because they're bisected. Okay? I think that's everything that we know so far, isn't it? Yep. It is. All right, again, what was the key to this? If what? If it's a parallelogram, then all that stuff is true. Okay? Then blah, blah, blah. All right? What we're going to do, I mentioned this word earlier before I even started recording. Remember I talked about the title of the lesson? You could say something about these being converses of each other. So what is the converse of a statement? I think we skipped a chapter where we talked a lot about if-then statements. Not saying that it's not important, but for what we're doing in here, I just decided it was better to skip it. So this is the if part right here. This is the then part. This is what we do a lot of times in not just geometry, but in like logic classes. The if they use as the letter P, the then they use as a Q, and then they put an arrow. So what does this mean? If what? If P, then what? Q. If P, then Q. So what's the P right here? It's a parallelogram. What's the Q? Well, it could be a bunch of these things, right? The opposite sides are parallel, the opposite sides are equal, the opposite angles are equal, all that kind of stuff. Okay, that's the Q. You with me on that? So that's the statement itself. When I take the converse of something, what I do is just reverse the P and the Q. So what would this be? What would the converse of a statement be? If what? If Q, then what? Then P. You with me on that? So what we're going to do is we're going to switch the if and the then. So what we're going to do today is say this. If the opposite sides are parallel to each other, then what is the thing? It's a parallelogram. Do you see the difference? So I start off not knowing that it's a parallelogram. All I know is I got this four-sided figure, and I know the opposite sides are parallel to each other, okay? You with me on that? So what if I have that? What if I have something, a four-sided figure, and the opposite sides are parallel to each other? Then what is it? It's a parallelogram. That's why they call it the proofs of parallelograms. So what I'm going to do is I'm going to go through all this information right here, but my assumption at the beginning is I don't know that it's a parallelogram to begin with, okay? But they're going to tell me stuff about this quadrilateral, this four-sided figure, okay? So if this stuff is true about it, then it must be a parallelogram. All right, so let me copy this. So it's going to look really, really familiar to what we just finished doing, but there's a big difference, okay? The big difference is we don't know that we started with a parallelogram, okay? Right now, do I know that's a parallelogram with the information that's on the screen right now? No, I don't, okay? Because I didn't say it's a parallelogram. How did I know the other one was a parallelogram? How did I know this was a parallelogram to begin with? I said it was. Exactly right, okay? That thing right there, I was given, right? It was given to me that this is a parallelogram. So if I already know it's a parallelogram, I know all that stuff about it, okay? I know the opposite sides are parallel, opposite sides are equal, opposite angles are equal, blah, blah, blah. But this time, did I say that that's a parallelogram? Nope. But watch this. What if I knew that this and this were parallel? Just knowing those two are parallel is not enough. What else would I have to know? That the other two are parallel. Okay? So what if I have this situation right here? This is all the information that I know. Okay? I got a four-sided figure, and I know the opposite sides are parallel to each other. Now, what could I call this thing? This is now a parallelogram. That's correct. You with me on that? So I didn't tell you it was a parallelogram to begin with, but I gave you some information about it. I said the opposite sides were parallel to each other. That makes this a parallelogram. So if I was to write it, I would say, let me write it the way they say it. I was going to try to reword it a little bit, but it says a quadrilateral, and I'm going to write it more as an if-then statement after this. So I'll just shorten quadrilateral. Quadrilateral is a parallelogram if both pairs, I'm not going to do this for everything, I'll just do it for the first one. If both pairs of opposite sides are equal or congruent. Let's use the word congruent. Okay? So you could rewrite it like this. If, I don't know, I keep writing the F first. Okay, if you have a quadrilateral with with both pairs of opposite sides parallel, oh, I put equal. I should have put parallel. Sorry about that. Okay? So if you have a quadrilateral with both pairs of opposite sides parallel to each other, then, okay, so I want to write the if and the then. I think that's important for you to see. All I'm doing is rewriting this, just writing it a little bit wordier, all right, just so that you see the if and the then. So if you have a quadrilateral with both pairs of opposite sides parallel to each other, do we have that here? Yes. Then it's a what? A parallelogram. Okay? What did it used to say? It used to say, if it's a parallelogram, then both pairs of opposite sides are parallel. Remember that? That was yesterday. All right, so, but we just switched the if and the then. Instead of being if P then Q, what is it? If Q then P. Make sense? All right. I know I'm harping on that a lot, but I think it's important for you to see, especially for the first one. The rest of them are pretty simple. Here's another one. What if, let's get out of that. Okay, there we go. What if you knew that this side and this side were equal, and this side and this side were equal? So what if you knew both pairs of opposite sides were congruent to each other or equal to each other? What could you now say about this whole four-sided figure? It's a parallelogram. Now it's a parallelogram, okay? When it looked like this, you didn't know it was a parallelogram, did you? Okay? But, let's not do that. But when you did this, that turns it into a parallelogram. That makes it a parallelogram. We good? All right. So everything we've done so far is basically the converse of something we've done before. But here's one thing that's different. This is the one thing that's different. So, Mickey, you getting all this? Okay. Should be paying attention up here. So watch. What if this side was equal to that side? Is that enough to make that a parallelogram? It's not. But watch this. What if this side, the same two sides that are equal to each other, are also parallel to each other? That right there, I don't even know anything about this left side and this right side. All I know is the one on top is equal to the one on the bottom, and the same two sides are parallel to each other. That's all I need to know. If that's all I know, what do you think I can say about this thing? It's a parallelogram, okay? So I don't even have to know that both pairs of opposite sides are parallel to each other, do I? All right? Everybody got that? All right, so I think that's pretty important. All right, so that's kind of a new one. We didn't really do that before, but now that's a new one. All right. What else do we know? We know stuff about the angles, okay? So what if I knew that these two angles were equal to each other? Is that alone right there enough to know that it's a parallelogram? No, not just one set, but what if I knew the other set were also equal to each other? Yes. That's enough to know that now we have a what? Parallelogram, okay? We say parallelogram a lot in here. All right? Everybody got it? That's the proof, okay? I just showed you this is a parallelogram. Why do I know it's a parallelogram? Because both pairs of opposite sides are equal to each other. Or angles, I should say. Angles are equal to each other, congruent to each other. All right? Then we got another one. What are we leaving out? The one with the diagonals, right? So what if I had two diagonals? And what if I knew that this was equal to this, and this one was equal to this one? So what do I know? I know the diagonals do what to each other now? They bisect each other, that's right. So what do I know about a four-sided figure? If the diagonals bisect each other, then this whole thing has got to be a what? Parallelogram. So if this is all you know, what else could you say about this? Oh, you could say that the opposite sides are equal, right? So this one and this one and this one and this one are equal. You could say the opposite angles are equal. You could say the opposite angles are supplementary. Okay, all that good stuff, right? You could say just because you knew the diagonals bisect each other. So if the diagonals bisect each other, you know it's a parallelogram. Do you see the subtle difference between what we learned before and what we're doing today? All right, good. All right, that's that. Now I got a couple examples to do. Let's see how we're going to use this. It's really, the problems are very, very similar to what you just finished doing, except there's a little bit of nuance to the question. It's a little different, okay, that they're asking what they asked before, okay? Because before they said, all right, here's this thing. It's a parallelogram. Solve for X, or solve for this side, or solve for this angle, or whatever, okay? But this time, they're not going to do that. They're going to say, all right, you tell me what should X equal in order for this thing to be a parallelogram, all right? So they don't tell you it's a parallelogram to begin with, but the math is really the same. It's not anything different, but what you're finding is slightly different. So let's do this. There's our parallelogram. Let's just make it look a little different. I'm going to just turn it a little bit. Well, the first one's got 3 parts to it, and the second one's got 2 parts to it. So that would be 5, if my math is correct. All right, so here we go. We got this is D, E, F, and G. All right, and they tell you this. They tell you that, let's do a different color. They tell you that this is equal to this, and they tell you that this is 108 degrees, and this is 70, let's try that again, 72 degrees. Okay? So it says, determine whether this quadrilateral can be shown to be a parallelogram. So, is this a parallelogram? Well, okay, we only got one pair of opposite sides, but what do we got about these angles? They're not the same. They're what? They're supplementary. So, what do you know is true about this thing if the consecutive angles are supplementary? Then it's a parallelogram. That's right. Because we didn't really talk about it up here. We probably should have. We did talk about the angles. Oh, I just erased all those every time. But remember, we said the opposite angles are equal to each other. And I should have said this, but if you can show that the consecutive angles are supplementary, then it's a, well, it's not just that though, all right? These are supplementary. So if these are supplementary, what does that mean about D, G, and EF? They're what? This would be the transversal. This line and this line would be what? If these two angles, if the consecutive interior angles are supplementary, what must be true about these two lines? They must be parallel to each other. That's right. So watch. So that and that are parallel. How do I know they're parallel? Because these two right here are supplementary. If these are supplementary, then this and this are parallel. Now check out what we got. Now I have one set of sides that are both what? Parallel and equal or congruent to each other. Do you see it? This side right here and this side right here, they're parallel to each other. We just figured that out because of those angles. And they're equal to each other. We knew that because they told us. So this has one set of opposite sides that are both parallel and equal to each other. Therefore, this thing is a what? Parallelogram. So I would say yes, it's a parallelogram. Okay? Let's do another one. Let's keep that white. Oops. All right. What if I told you this? This looks like it's 90 degrees, doesn't it? But can you make any assumptions about it being 90 degrees? No. So just keep that in mind. All right. All right. What if I told you that this one and this one were equal to each other? Okay. And what if I told you that this one was equal to this one? Does that make it a parallelogram? Because look at the opposite angles. Are the opposite angles equal to each other? The opposite angles, look at the opposite angles. Are they equal to each other? No, they're not. This has one arc, that has two arcs. So these are not, the opposite angles are not equal to each other. So guess what? This is not a what? This is not a parallelogram. You with me on that?
Yeah. Would it be a parallelogram if you didn't label those two top angles?
No. Because look, here I think I can draw something that fits this, and I can show you that it's not a parallelogram. Watch. Look, these two look like they're equal to each other, right? These two look like they're equal to each other. Is that a parallelogram? No, because that definitely is not parallel to that. Do you agree? But these top two are equal, and we're going to do something with this. What is this, by the way? I think we've talked about this. It's a trapezoid. We're going to talk more specifically about a trapezoid later, okay? But that is definitely not a parallelogram. Agreed? Okay. All right, let's do another one. All right, what if I had that, and I said that this was a right angle and this was a right angle? Is that enough to say that that's a parallelogram? Well, we got one set of equal angles, right? So that definitely means that this and this are equal to, or not equal, but parallel to each other. Would you agree? Because these add up to 180, so they're consecutive interior angles. They add up to 180. They're supplementary, which means that and that. Does that mean this is a parallelogram, though? No, because we don't know that this is straight up and down, do we? This might be tilted like at a 0.001 degree. Would you agree with that? And this could still be parallel to this, but this one, it might look like this, right? It might be like that. Do you agree? So would that be a parallelogram? No, it wouldn't. So just knowing that these are supplementary to each other or even equal to each other does not mean that the others are going to be supplementary as well. Okay? So that's really important. All right, so what would we say about this? No. Okay, we don't know. We don't know that that's a parallelogram. All right, let's do another example. That was example one. There was 3 different parts to example one. That was just example one. This one you're going to do a little math with. Okay? I'm going to say there's 2 parts to this example. All right, here we go. Everybody watching? Let's label it. This is Q, R, S, P. T is in the middle, right there. And let's put some stuff inside. So this is 5A. This is 20. This is 6B plus 2. And this is 7B minus 4. All right, so here's the question. This looks very similar to what you just did, doesn't it? Except in the problems that you did on the other lesson, what did they tell you about this quadrilateral? They said it was a what? A parallelogram. So you worked under the assumption that it was a parallelogram, all right? Which means if it was a parallelogram, you know the diagonals would bisect each other. So this and this would equal, this and this would equal. You'd solve for A, you'd solve for B. No biggie, right? The math is exactly the same. It's just the problem is slightly different. It's a subtle difference. This says let me read the problem. It says find the value for each variable that ensures that this quadrilateral is a parallelogram. All right? Fight it. I know you're trying. Fight it. Stand up if you need to. Shake it off. All right? So let's watch. So we don't know this is a parallelogram, but what does A need to equal and what does B need to equal in order to make it a parallelogram? Okay, well, 4 for A, right? So what do? We'd say that 5A needs to equal 20. If 5A equals 20, that's part of this being a parallelogram, right? Because they bisect each other, right? Divide by 5, A is 4, easy. And then, what can we do with these two? If they bisect each other, then it's a parallelogram. So that means if these are equal to each other, then it's a parallelogram, correct? So I'm going to go 7b minus 4 needs to equal what? 6b plus 2. Subtract 6b, you get b. Add a 4, you get 6. So if a is equal to 4 and if b is equal to 6, then this thing is a what? Parallelogram. You see the difference in the question? It's a subtle difference. A lot of people think, why even bother doing this? Okay, because you're kind of doing the same thing as what you did before. But again, we did not know it was a parallelogram. What does A and B have to equal in order to make this into a parallelogram? And that's what it has to equal, 4 and 6. We good? Let's do one more. It's just as easy. Okay. A, B, C, D. A, B, C, and D. And then they give you this to be 2x. This is y plus 14. This is x plus 11. This is where we're going to do that substitution math we did yesterday. Okay. Let's just push this over off to the side. Give me some room to write. Okay, here we go. Everybody good? So here's the question. Again, same question. Okay, what does x and y have to equal in order to make this into a parallelogram? Again, we don't know it's a parallelogram yet, but if I knew the correct x and the correct y, I could make this into a parallelogram. I could ensure, that's where they use, ensure that it's a parallelogram. So what should I have to do? What must be true about the two sides if this was to be a parallelogram? They got to equal each other. So guess what I'm going to do? 2x equals what? Y plus 14. I got two different variables. I need another equation, don't I? All right, so where's my other equation? Yeah, let's just go y equals. Is that all right? Y equals x plus 11. All right, so both those things must be true in order for this to be a parallelogram. So let's solve for x and y. So what am I going to do here? Do a little substitution, correct? So y is sitting here by itself. Y is x plus 11, so guess where I'm going to put that? In for the other y in the other equation. So let's rewrite this. I got 2x plus y. What did I say y was? X plus 11. So plus x plus 11. And then it was y what? Y plus 14. So there we go. So this is what x should equal. Did I do that right? No. I put a plus here. Why did I put a plus? 2x equals, right? So 2x equals y plus 14. This right here is the y from down here. And now I can solve. Subtract an x from both sides. So 2x minus x is x. Add these, 25. And there's x. It's just 25. Okay? And then I got to solve for y. Y is super easy now because y is already sitting here by itself. Y is equal to x plus 11. So it's just 25 plus 11. So y is what? 36. So that's what y needs to equal, and that's what x needs to equal, and that's what y needs to equal in order to make this into a parallelogram. I think that's it. All right, so I gave you just 18 to 25. I don't know what was wrong with 1 to 17, but I wrote down 18 to 25. So this is section, what is it, 6-3? It's not A or B. And page 267. There's your homework. Say that again. Yeah, okay. It's on facts, but we actually kept up to date this week. Okay, every single day we were right on track, so that's good. It's kind of rare, isn't it? Usually, sometimes we go ahead, sometimes we fall behind. Most of the time, we fall behind. It seems like, but we're right on time this week. So yeah, we'll probably have a quiz next week on this. I forget exactly what it covers. Maybe I'll go and look and let you know. Yeah, you can.